Hello, good afternoon. My name is Jessica Nachulija, and this is Group 19. Our project is contrastive physiochemical self-supervised learning and knowledge distillation for wine quality prediction. Then our problem statement basically looks at like how wine has been tested before and how we are planning to test it, whereby wine was tested through human experts, whereby that method could be expensive and costly. So our problem statement basically needs an automated, objective, and efficient method to predict quality based on measurable physiochemical properties. Then the project objectives, one is we predict wine quality using physical chemical data. Then we shall use the different techniques to make it efficient, whereby that is contrastive learning and knowledge distillation. Then we shall inform the production processes, even commercialization and IP protection. For the solution overview, you see we shall have contrastive learning and the models that shall be trained there. We have Siamese NN and convolutional neural networks. Then under knowledge distillation, we have the models that we train under the knowledge distillation, even the wine quality, whether it is low or high. Then here we utilize unlabeled data for feature extraction and distilled knowledge from complex, simpler, deployable models. That is basically under the knowledge distillation from complex to the simple model. Then the data used, we use the red wine data set from the UCI, the features. We have 11 physical chemical features. The size is 1599 samples. The quality is basically within the range of 0 to 10, whereby 0 to 5 is low and 5 to 6 is high. The pre-processing, it is like duplicates were removed through the SMOT application. Here you can see the before SMOT, whereby the data was imbalanced. Then this one shows the data was balanced. Before SMOT and after SMOT. Then the models and the techniques, we have we have contrastive learning, and under this we trained models such as the Siamese network, then the CNN. Then under the technique of knowledge distillation, we had the teacher models and the student models, whereby the teacher models were used to teach the student models. Yeah, and whereby under all this, the graded boosting excels due to the ensemble strength. As you can see, the performance of each model. Yeah. Then this one shows the architecture, whereby the data, you enter the data, you train, you model, you save, then you deploy it with a Streamlit, whereby the user can input, process, predict, then you get the results. Implementation details, we use Python, which is the primary language, the TensorFlow, the scikit-learn, and then with the web deployment, we use the Streamlit, even Google Colab for training. Results and evaluation, metric accuracy, the weighted F1 score, the top performer, we got graduate boosting with an accuracy of 0.790 and F1 of 0.789. Then let me invite my colleague. Yes, good afternoon, everyone. This is Rose Mirakot, and I'll be mainly taking you through the relevancy, then the intellectual property, and the innovative part of our work. So, talking about impact and global reliance, in the context of our country, it enhances local wine production through quality control. Then globally, it reduces reliance on human testers. That's worldwide. Then for sustainable development, our project aligns with the SDG goal, and that is the SDG goal number 9, that mainly focuses on industry and innovation. It also covers the SDG 12, that is that one that is under deals with sustainable development.
Then looking at the winemakers and certification bodies and distributors, they can also benefit from this project. Then, so on the intellectual property and innovation, so our project doesn't stand alone. It is based on other approaches that have been investigated. First, it was a traditional approach, was dependent on human testers, and this was subjective, slow, and also expensive. Then away from the traditional method, we also look through other studies that have been going on, mostly from the IEE community, and we saw that they mainly focus on the, can I say that the supervised approach that mainly focuses on random forest and the support vector machine. So what is the innovative part of ours? Ours, it combines the contrastive learning, which focuses on the unbalanced data. Then also it it integrates the knowledge distillation file that enables the simpler models to learn from the parent models for efficiency. So talking about, we have our algorithm, then also we have our cooperated code that would need a part right or a copyright role. Then from that, we also have our potential app name as our trademark that we need to be copyrighted. Away from that, so this also offers us an opportunity based on the most important features which we outlined as alcohol, and also offers like a web app for predicting quality, and that encompasses the quality of our project. Talking about the monetization, the money part of it, how are we involved in this? We have the API licensing to expand maybe usage and usage scenarios. Let me say that. We have the subscription model, and this one is in very many forms. How monthly, yearly, then there are also those who based on paper prediction. Then we also hope to commercialize it, maybe let me say the wineries, also the winemakers, even the wine enthusiasts. Then this is a simple demo of how our project works, like how our web app works. I'll play it later. Then here I didn't work as an independent person. I worked with my colleague and had several roles, so consulting each other. But the key she handled data processing, contrastive learning, and implementation. And on the other hand, I handled knowledge distillation, web deployment, and integrating the concept paper. Then we also have the lesson done. And one lesson is we learned and the challenges is one was learned the importance of the balance. Like we couldn't make a prediction with varying data points, so we had to balance them. Then we also learned to what, like we have the sample model security. We learn to integrate it with other weaker models. Then we also learn the feature importance, like there are features that are more important for predicting the quality other than others. Then the challenges was imbalanced data set, like gave us at times giving us varying accuracies in prediction. Then high computational cost of neural network. This is because the models are overfitting. Then our future work mainly aims at enhancing and expanding capabilities, and one of them is the data expansion through incorporating maybe white wine and maybe increase sample size to improve model generation. Then we also have the real-time monitoring with MLflow for continuous monitoring and optimization of model performance. We shall also have the API development to create a robust API to facilitate broader integration across various platforms and services. Then we also shall also do optimization to streamline for deployment in those trained environment to ensure accessibility. So our conclusion is mainly here that we are transforming the wine quality assessment from art to science. What do you mean? The art part of it involves human testers whose skills were subjective, slow, and also expensive. So we are moving it to the science part of it that involves using data and machine learning models, which is very efficient, fast, and also scalable. So the last thing, let me take you through our demo. So this is our demo. When you have your wine samples, you simply go to Streamlink, access our web app. Then after accessing our web app, your wine has properties like the physiochemical properties. You can enter, as you can see, you can also increase the decimal points if it has or reduce. Then after entering all that, those are all the fields for entering. After entering all that, we have a deploy button. So when you click on this predict button, it should be able to tell you that the good quality it's a good quality wine with a quality score of 6.31, until we gave a quality rating of 0 to 5 as low bad quality wine, then we had 6 to 10 as good high quality wine. Thank you. That is the end of our presentation.